In this lesson, we're going to discuss how to solve a system of equation, whether it is 3 equations or 2 equations, using the Gaussian method. So let's take a closer look at this system of 3 equations. Now, before I do anything, I have to change this into an augmented matrix. What is an augmented matrix? The augmented matrix will have the x in the first column, the y in a second column, the z in a third column, and all the constants in the fourth column. So I have to have my equation in standard form, which means x, y, z has to be on one side and the constant has to be on the other. So let's take a look at the first equation. What's the x? There's no x, so I'm going to put a 0. The y has a coefficient of 2. The z has a coefficient of 1, and the constant is -8. So what you do is you take the coefficient of every single variable. In the second equation, the x has a coefficient of 1, then we have a -2, -3, and then a 0. So let's write that down. Now let's take a look at the third equation. That's a -1, that's a 1, that's a 2, and that's a 3. So -1, 1, 2, and 3. Now if you want, you can draw like a dotted line between the constant and the x, y, z to represent the equal sign. Now this is called an augmented matrix. And every time you use Gaussian method to solve an augmented matrix, your job is to have a 1 over here, a 1 in the left top corner, and you need to have zeros over here. So basically in this triangle over here, in the bottom left corner. So how do we do that? What are some of the things that you're allowed to do in a matrix? You can swap 2 rows, and I think that would be a good method in this example because as you can see, you have a 1. So if I swap row 2 and row 1, I will have a 1 up there and I will have a 0 down here. And this is what you need to do. You have to have a 1, 0, 0, and a 0. So you can swap 2 different rows. You can multiply a row by a constant number, whether it's positive or negative. You can also add 2 different rows. So for example, if I add the second and the third row, 1 minus 1, that's a 0. So you can add 2 rows and place it in a certain row. So if you have 4 rows or 3 rows and 4 columns, every single time you have to have 3 rows and 4 columns. Now let's go ahead and think. What's the first thing? So remember, you need to have a 1, a 0, a 0, and a 0 over here. And like numbers and everywhere else. Now the idea behind that is, like since we have numbers over here and we have a 0 and a 0 over here, I know that the third column is a z. So in this case, I know that z is equal to a number. So that's the constant column. Is z is equal to a number. Here I have y and this is z. Since I found z in the third column, I can plug it in and then I will be able to find y and so on. Once I find y and z, it will be easy for me to find x. So your main aim is to have a 1 up here and zeros in this bottom corner. Now let's see what we can do. What if we swap, for example, remember that the first one is row 1, the second one is row 2, and the third one is row 3. So what if we swap row 1 and row 2? Then my new augmented matrix will be 1, -2, -3, 0, 0, 2, 1, -8, -1, 1, 2, and 3. There you go. I found a 1, and that's what I want. I got this part, okay? Now, and I also got this part. Now I still need zeros over here. So what can I do? If I add the first and the third row, 1 plus -1, that's a 0. And I place the addition in the third row. So what I'm going to do is I'm going to add row 1 and row 3 and place that in row 3. So what does that mean? That means I'm not going to change row 1. I'm going to keep it as it is. I'm not going to change row 2. I'm going to keep it as it is. And row 3 is going to change. Row 3 will become now the addition of row 1 and row 3. Now, the new row 3 is going to be the addition of row 1 and row 3. So 1 plus negative 1 is a 0. Negative 2 plus 1 is a negative 1. Negative 3 plus 2 is another negative 1. And 0 plus 3 is 3. So that's my new row 3. Now, as you can see, I have a 1. I have a 0, I have a 0, and now I still need a 0 in this place over here. So what can I do? Remember, you can swap rows. You can multiply a row by a constant number, positive or negative, it doesn't matter. You can add rows and place them in another row. So, what if I multiply row 3 by 2, because 2 plus negative 2 becomes 0. So what if I multiply row 3 by 2 and add row 2 to it? So I'm going to keep row 1 and row 2 as they are because I reached my aim. I need a 1, I need a 0, and I have that. I need still 0 over here and 0 over here. I have the 0. I still need a 0 in this area over here. So I'm going to keep row 1 and row 2 as they are. Row 3, however, I'm going to multiply it by 2 and add it to row 2. So I'm going to add row 2 to 2 times row 3. So let's see what this will give me. So I'm going to keep the first row as it is. I'm going to keep the second row as it is. And now row 3, I need to multiply by 2 and add it to row 2. And that's going to be my new row 3. So I need to put that that's going to be my new row 3. Okay? Now, if I multiply this by 2, 0 times 2 is a 0, plus 0, that's a 0. Now, if I multiply this by 2, negative 1 times 2 is a 2, plus 2, that's a 0. That's what I want. Negative 1 times 2 is negative 2, plus 1, that's a negative 1. And 2 times 3 is a 6, plus negative 8, that's going to be a negative 2. So let's zoom out and let's see if I got what I wanted. I have a 1, I have a 0 in the corner in a triangle form. In the bottom corner, I have a 1 in the top left corner. So that's what I want. I'm done with the matrix. Now I need to change these numbers into 3 different equations. So remember that the first column is x, the second column is y, and the third column is z, and the last part or last column is going to be my constant. So if I look at the last row, that's going to give me negative 1z equals negative 2. Second row, that's going to give me 2y plus z, that's a negative 8. And if I look at the top row, the first row, 1x minus 2y minus 3z, that's going to be equal to 0. Now from the third row, I can get z. Z is equal to 2. Now if I plug it in my second equation, 2y plus 2 equals negative 8. 2y equals negative 10. And y is equal to negative 5. So I just found z and y. So 1x minus 2, I got y to be negative 5 minus 3 times 2. So x plus 10 minus 6 is equal to 0. X plus 4 equals to 0, so x is equal to negative 4. So my final answer is going to be negative 4, negative 5, and 2. And that's how you solve a system of 3 equations using Gaussian elimination. Now let's go ahead and move on to a system of 2 equations. Now the first thing you need to do is to change this to an augmented matrix. So the first rows, that's 1, 5, and 7. There you go. -2, -7, -5, so I need to fix this. If you want, you can have a dotted line in the middle before the constant to show where the equal sign is, okay? Now your aim here, since you don't have a triangle, so your aim is to have a 1 up in the top left corner and a 0 in the bottom left corner. That's your aim. Now, as you can see, the first one is already done. I need now to try to find a 0 over here. So remember, the same rules apply. You can swap two rows. You can multiply a row by a constant, whether negative or positive, and you can add rows. So what if I multiply the top row by 2 and add it to the second row, because 2 plus -2 is a 0. So let's try that. I'm going to keep row 1 as it is, and what I'm going to do is I'm multiplying the first row by 2 and adding it to row 2. So I'm multiplying the first row by 2 and adding it to row 2, and I'm placing that in row 2. So I'm not going to change my first row. And now I need to multiply the top row by 2 and add it to the second row. So 2 times 1 is a 2, plus -2, that's a 0. 2 times 5 is a 10, plus -7, that's a 3. 2 times 7 is 14, minus 5, that's a 9. So that is my new matrix, and that's what I want. And the reason I just need that, because remember, the first column is x, the second column is y. Since I don't have a z, I don't have a third column with the variables, I just have the constant. And that shows me that 1x plus 5y, that's equal to 7. And 0x, I don't have to write that down, plus 3y equals to 9. Now from the second equation, I can get y to be equals to 3. Now if I plug 3 for y, I will get my x. So x plus 15 equals to 7. X is equal to -8. And that's my solution, -8, 3. And that's how you solve a system of two equations using Gaussian method.